Superposition in the frequency domain works much the same as it does in the time domain. You'll zero all of the independent sources but one. You'll always keep all of the dependent sources on. If all the sources have the same frequency, then you'll add all the partials, where I'm calling a partial the amount of output caused by each independent source. You'll add all those partials in the frequency domain. Then you'll convert the one remaining phasor to the time domain. If the sources are of different frequencies, then you'll convert each phasor, each partial phasor to the time domain. Then you'll convert each partial phasor to the time domain first, and then you'll add everything up in the time domain. So the reason for this is that here, there's only one set of frequencies. So therefore, you can add all those different partials as phasors to get just one phasor. But here, you have lots of frequencies. So you couldn't possibly add them in the frequency domain because they all have different omegas. When you try to convert them back in the time domain at the end, which omega would you use for your one phasor? Whereas here, by converting them to the phasor, by converting each phasor to the time domain, you can use all the different omegas for each conversion. And then when you add them, you'll have a sum of a bunch of different frequencies. So as an example of what I'm talking about, let's say we had 4 different independent sources. We had a 16-volt DC source. We had a 5 cosine of 10t minus 53 degrees source. We had a 14 cosine of 10t plus 6 degrees source. And we had a 5 sine of 20t source. Maybe these are voltage sources, maybe these are current sources. Here's a voltage source, here's a current source, here's another current source. But the important thing to realize is that this has a frequency of 0. These two have the same frequencies, and this has another different frequency. Each of these independent sources will give rise to a partial output. When you examine just the effects of the 16-volt source, everything else gets zeroed. So this voltage source will look like a short, this will look like an open, and this will look like an open. And let's say that the 16-volt source gave a partial output of 2 volts. You'd have to analyze the circuit to figure that out. Let's say this 5-volt cosine source gave, in the frequency domain, this partial. Let's say this one gave this partial. So the output that we want to measure is a particular voltage. So all these things will have units of voltages at the output. Now, these two are of the same frequency. So we can phasor add them to get their sum. And now we've got one unique phasor output for each different frequency. This is at omega 0, this is at omega 10, this is omega 20. And so now we can convert them to the time domain. 2 volts at an omega of 0 is just 2 volts. This at an omega of 10 looks like this. And this at an omega of 20 looks like this. And now we just add them all together in the time domain to find our desired full output.